Okay, so let's move along now to our second principle of experimental design. That's randomized. So we've already sort of talked about that. And I kind of feel like these principles, they're not necessarily mutually exclusive. Some of them are overlapping in certain ways. So one way that we can control is through the process of randomizing. So when we say that we randomize in an experimental design, it means that we're using impersonal chance to assign subjects to treatments. So this is all about how we're assigning subjects to treatments. So we assume to begin with that we've obtained a random sample or a representative sample of the population. Once we have that sample, we randomize or randomly assign them to different treatments so that, again, we can hopefully create a situation where at the very beginning of our study, before we've actually imposed the treatment or the explanatory variable, that the different groups are as similar as possible. So we're trying to start with groups that are very similar at the start of the study in terms of all the possible lurking variables that could come into play. And hopefully then the only difference among the groups will be the treatment that is applied or the explanatory variable. What does this do for us? It helps to reduce bias. So you might remember that term from earlier. What is bias? So what does it mean when I say we're helping to reduce bias? What does that mean in an experimental setting? So a hint is that, think back to what we talked about when we initially talked about this idea of bias. So you have bias if you have a study where you're systematically favoring certain outcomes. So more often than not, outcomes are going to go in a particular direction. And because of that, you might end up reaching a conclusion that's not really accurate, that doesn't really represent what's actually going on in the population. I wanted to try to illustrate this because I do understand that this idea of bias is challenging, and I wanted to try to illustrate what this all means and how we use bias in different ways throughout the semester in different contexts, and I wanted to try to compare those things for you so you can hopefully come up with a better understanding of what this all means. What I'm showing you here now is just an image from another book that I have. The book is called Visual Statistics. I really love this book. It's kind of old, but basically the book tries to take every concept in introductory statistics and create a picture to try to help individuals visualize what is meant by that concept or idea. And this is all about bias. So there are three examples here of bias. So a biased bathroom scale. So imagine that you stand on your scale, and every time you stand on the scale, it adds 10 pounds. There's something wrong with the scale, so it's not giving you an accurate measurement. Every time it's systematically giving you a measurement that's much higher than your actual weight. We'd say we have bias in terms of that measurement instrument. Here's a biased impression. So think about a biased sampling method. So you purchase a crate of oranges and you want to take a sample of the oranges, or you're thinking about purchasing a crate of oranges and you want to take a sample of oranges from this crate to make sure that all of the oranges are good. Well, if you just look at the top, it's possible that all the best oranges are put up on the top and all the really bad ones have sunk down to the bottom. So if you're just taking a convenient sample, looking at the top, looking at what's most convenient for you, rather than trying to take a true random sample of the entire crate, you might reach the wrong conclusion. You're going to systematically think that the oranges are good, when in reality they might not all be good. Here's bias in an experimental setting. So this is an example where they're talking about a study where they're trying to see if a particular cereal has an effect on rats, on the nutrition of rats. So imagine a study where some rats are given a new cereal, some are given an old cereal. And they talk about here the fact that, ideally you'd want to randomly assign rats to get these cereals, but what if all the rats who are getting the new cereal, they happen to be housed in an area where they're getting more exercise and they're getting more sunlight than the rats who are getting the old cereal. So there's not random assignment. The rats are just placed into groups, maybe depending on where they're housed in the laboratory where the study is being run. So if we see that maybe those who are getting the new cereal are healthier, we don't really know if it's because of the cereal or is it because of the sunshine they're getting, the housing conditions that they have that are different from the rats who are getting the old cereal. So there's a lurking variable there, or multiple lurking variables that we're not taking into control, and we're therefore biasing things in terms of systematically favoring a particular outcome. The outcome here being that the new cereal is going to be deemed better than the old cereal, not because of the cereal, but because of these other things that we haven't controlled for. So again, we want to randomize because we want to avoid bias in this way. We want to avoid saying that one treatment is better because of things we didn't control for. We really want to be able to say it's better after we have controlled for these other things, so that we can be as confident as possible that it's really the treatment that's making a difference and not other things. Again, I really hope that this is all making sense. I know it's kind of confusing here, and I'm talking way too much, but I hope this is making some sense. So, more statistics in the news. What are the best incentives for web surveys? So I like to talk about this incident that happened to me in my life. One day I got a letter in the mail from Gallup, the survey organization, Gallup polls. And I almost didn't open it. I thought it was junk mail at first, but then I thought, Gallup usually never sends me anything. I'm going to open it and see what it is. And it was a survey, so they wanted me to complete a survey. But in addition to sending me a survey, they sent me a dollar bill, which I was very surprised, a real dollar bill. And I'll be honest, getting that dollar bill was an incentive for me to complete the survey. I thought, wow, they're sending me money. I should do something to get this money, or to feel like I earned this money. So I completed the survey. They sent me a copy of the survey so I could have completed it by hand and sent it back in, and they also had a web link I could go to and complete the survey online. So I learned much later on, and actually a moral of the story here is that if you ever get anything in the mail from Gallup, you should open it because there might be a gift in there for you. But I learned later on that Gallup does studies like this from time to time, where they try to see if there are ways that they can incentivize individuals to actually complete surveys, to return surveys and fill out the surveys. So here's one particular study that was done not terribly long ago. So Gallup partnered with a university to see if different kinds of incentives, either prepaid or postpaid incentives, could affect whether individuals completed surveys. So they randomly assigned, so there was random assignment, they randomly assigned individuals to one of three groups. And again, as when you see now, when we tell you that we've randomly assigned, we hope that you're thinking about why we would be doing that, why that is important. Why would you want an experiment where there is random assignment? And again, we're doing that to attempt to control for many possible lurking variables, to make those groups as similar as possible at the start of the study. So they had these three groups. One group received no incentives at all. So they were just essentially sent a study or sent a survey, and then they were asked to complete the survey. Another group, they were given a prepaid incentive. So they were sent a survey, and in addition, a $5 gift card was included with that survey. And then there was a third group where they were sent a survey, and they were told, if you return this survey, or if you complete this survey, we will send you a $5 gift card. So the postpaid incentive versus prepaid. Okay. So, what do you think maybe happened here? Well, which group do you think maybe responded the most, had the highest response rate? So it turns out that those who got no incentives at all, 13% of them responded and returned the surveys. In the prepaid group, there were 19%, and in the post-paid group there was 20%. So I should mention here that I believe there were like 1,000 individuals in each of the incentive groups. And then in the no incentive groups, I know there were many more individuals, more than 1,000. So there were at least 1,000 in each group. So that might give you a sense of, what these percentages, or you might be better able to interpret these percentages by thinking about that. So what they found here essentially is that, certainly having some kind of incentive was better than no incentive. But whether it was prepaid or postpaid really didn't make that much of a difference. So the difference between the prepaid and postpaid incentive groups was not statistically significant. We'll talk more about what that means a little bit later. And we'll come back here to talk about how even though this wasn't a statistically significant difference, it could be what we consider a practically significant difference, especially for Gallup in terms of the money that they're spending in terms of trying to get people to complete these surveys. Okay, so quickly let's talk through one more example here of random assignment. So what do you think determines whether a sports team will win a game? I want you to think about what you think would determine that. So maybe think about your favorite sports teams, what OSU, the Bucks, what do you think determines whether they're going to win a game or not? Maybe you're thinking about the quality of coaching, how much practice the team gets, personalities of players on the team, their teamwork, how well they get along with each other, their fitness levels, how much exercise they get, how many weights they, or weight training. We could probably think about a lot of different things. I'm wondering if you're thinking about uniform color. Could the color of the uniform have an impact on whether a player or a team will win a game? Well, some researchers think yes, uniform color makes a difference. So let me tell you again about a study. Here's the headline: in sports, red is the winning color. I thought this was especially appropriate for OSU since scarlet and gray are the OSU colors. So let me tell you a little bit about the study. So this was a study that was conducted in 2004, and they were actually not really looking at team sports, but individual sports. So they were looking at wrestling, boxing, and taekwondo matches at the Olympic Games that year. And the researchers who were doing this study noticed that one player in the match would wear red and one would wear blue, and they assumed that the players were randomly assigned to wear these colors. And they wanted to see whether wearing one of those colors might lead to more wins than another color. And what they observed was that the athletes who were wearing red were more likely to win the matches. And so that's where this particular headline came from. Wearing red seems to make a difference in terms of whether you're going to win. And if you go and read this study, they make some theories as to why that might be the case. But there's a problem here. And the problem has to do with the random assignment, with assuming that there was random assignment. So it turns out that actually there was no random assignment. And this is a lot here to read through, but basically some other researchers came along and they said, wait a minute, we don't really think that when we have the Olympic Games that the players are randomly assigned to wear certain colors, and there are also some issues in terms of who is actually matched against or which players are actually matched against each other in different rounds of competition. So none of it is really random. And so there are other possible things going on here that could explain why those players who wore red just happened to win more during that particular Olympic game. And in fact, these other researchers looked at a following year of Olympics. I don't remember if it was 2008 or 2012, but in another year of the Olympics, they found that actually the players who were wearing blue were more likely to win. So They weren't really able to replicate what these original researchers had said was going on. So again, look for random assignment. Has there been random assignment? If there hasn't been random assignment, or if that assignment is questionable, then it's always possible that the results aren't really going to mean what we think they mean, that some lurking variable has come into play and is affecting the response. Okay, so we'll pause here and then we'll come back and talk about our last principle of experimental design.